Section 9.1, Part 5. Lesson objective. Construct and interpret a confidence interval for a population mean, assuming that the population standard deviation is known. Are you a couch potato? A recent general social survey, GSS for short, asked respondents on an average day, how many hours do you personally watch television? Below is a printout for the GSS variable TV. We see that there were 899 people asked. This was the mean. This was the standard deviation, and we have our 95% confidence interval. So let's answer the following questions. Identify the value of the point estimate of the population mu. What is the value of the margin of error, or MOE? Express the confidence interval in the format point estimate plus or minus margin of error. Write a statement that interprets this confidence interval. So number one, we believe that mu is between 2.69 and 3.04 hours. So if we think about this visually, this is our lower endpoint, this is our upper endpoint. So we know that this is x bar minus margin of error, and this value is x bar plus margin of error. So if we wanted to figure out x bar, we would simply take the upper limit plus the lower limit and divide that by 2. Because if I was to add this plus this, the e's would cancel and you would be left with 2x bar, and 2x bar divided by 2 is x bar. Now to find the margin of error, what we would do is we would take the upper limit minus the lower limit and divide that by 2. Because if we were to take this and subtract this, we would end up with the x bars canceling, and we would have e minus a negative e, which becomes 2e. 2e divided by 2 is e, which is the same thing as margin of error. Okay, so back to problem 1. Identify the point estimate of the population mu. So if we take our upper plus our lower and divide it by 2, we get 2.865, and that agrees with this up here. If you don't know x bar, you can compute it just by knowing the lower bound and the upper bound. For the margin of error, we take the upper limit minus the lower limit, divide that by 2, which gives us 0.175. Number 3, express the confidence interval in the format point estimate plus or minus margin of error. So from problem number 1, we know that our point estimate x bar is 2.865. From the last problem, our margin of error was 0.175. So to express this confidence interval as point estimate plus or minus margin of error would look like this. Write a statement that interprets this confidence interval. We are 95% confident that the true population mean for watching television on an average day is between 2.69 hours and 3.04 hours. When 13 second-year medical students at Belleville Hospital measured the blood pressure of the same person, they obtained the results. So here's our raw data: 138, 130, 135, so on and so forth. Assuming that the population standard deviation is 10 mmHg, construct a 90% confidence interval estimate for the population mean. Interpret this interval. B, ideally, what should the confidence interval be in this situation? Well, if we put this raw data into Minitab, or you could do StatCrunch, we compute the confidence interval, and from that we can make our interpretation. We are 90% confident that the true mean for this person's blood pressure is between 129.7 mmHg and 138.8 mmHg. Part B, ideally all these measurements would be the same, so there would be no need for an interval estimate. Our last example. In a study of the length of time that students required to earn bachelor's degrees, 80 students are randomly selected and they are found to have a mean of 4.8 years. And this is based on the data from the National Center of Education Statistics. Assuming that sigma is 2.2 years, construct a 95% confidence interval for the population mean. Interpret this interval. B. Does the resulting confidence interval contradict the fact that 39% earned their bachelor's degrees in 4 years? We'll begin with A. So from Minitab, here's our confidence interval. If we were to interpret this, we would say we are 95% confident that the true population mean for getting a bachelor's degree is between 4.3 years and 5.3 years. Part B. No, because the confidence interval is an estimate of the mean, and it does not imply that 95% of the times are between the confidence interval limits. Here's the suggested problems and the readings from the book. Thanks for watching.